This is question number 11 from the 4B My Math Lab homework. And in this question, we're told that $4,000 is deposited into an account that pays an APR of 6% compounded annually. Then we're asked, how long will it take for the balance to reach $120,000? So we need to do a couple of things here. We need to figure out which row of the formula chart we should be using. We need to figure out which formula we're needing to use, and then we need to pick out the given information and put it in the right place. And then we got to put in our calculator correctly. So lots of moving parts to this problem. But let's think about the scenario. What is happening here? We are making a one-time deposit of $4,000. So there are no repeated payments. That $4,000 is being deposited, and then it's just going to sit there. And in this case, it's going to earn money for us, right? And it's earning a compounded interest. So I'm going to pop over here to my formula chart. This is our flow chart that helps us figure out which of the 4 rows of the formula chart we should be in. So our first question was, are we making a lump sum deposit that just sits there, or are we making repeated payments? And we already talked about making a lump sum deposit that's just going to sit there. And then your next question is the interest compound? And we saw the word compound annually, so yes, it is. So we're going to end up in that second row of our formula chart. So I'm going to hop over here to our formula chart. There it is. Woo! And we're going to go to the second row. So we're here with our compound interest. That's our second row of our formula chart. And we just have to figure out which of these formulas to use. And that depends what we're looking for. What are we wanting to calculate? Well, the question asks us how long it would take. So we're trying to find the number of years. This formula, y equals, calculates the time for me based on all these other factors. So that's the formula we're going to use. And it can be a kind of tricky one, right? We see that we have logs involved, so there'll be a log button on your calculator. You don't have to know what a log is. In math, we always need an ability to undo something, right? So if we have an unknown that has 5 added to it, we subtract 5. If we have an unknown that's been squared, we square root it. If we have an unknown that's part of an exponent, the log is the inverse function for exponential. So we just use logs to find an unknown that's in an exponent. And luckily we've done all the algebra for you to isolate the y, to isolate the time. All you have to do is write this formula down exactly like you see it, plug the information into the correct places, and put it in your calculator correctly, which is easier said than done. So let's practice that. So I'm going to go back to our problem. Okay, so what do we need for this formula? We need an A, that's the future amount. We need the P, the principal that's initially deposited. We need our APR. We need the number of compounding periods. And that's it. That'll calculate. If we know all the information, it'll calculate the time. So let's go ahead and pick out all that info. Okay, wherever I see an A, I'm going to write the future amount, which is $120,000. Wherever I see a P, I'm going to write the initial deposit, which was $4,000. Where my APR was 6.9%, which we translate to or convert to a decimal. It was compounded annually, which means 1 time a year. And we were looking for time. Oops, I wrote a T there. It should be a Y for year. We're looking for our time in years. So I need to get this into my calculator. Now, everyone's calculator is a little bit different. I'm going to show you how to enter this in the Desmos scientific calculator. Your calculator might be different. The important thing is that all the parentheses you need have been typed for you. For the typical scientific calculator. But if you're having trouble, come see us in office hours and we can take a look at your specific calculator. So before I hop over to Desmos, let me talk about this a little bit, this entry that I'm going to do in my calculator. So I'm going to start by entering this numerator. So I'm going to hit my log button on my calculator, which will probably automatically pop up in parentheses. Then I'll type my 120,000, my division button, and 4,000, and close that parentheses. Then I have another division bar. That fraction bar is like division, so I'm going to hit my division bar. Then I'm going to type the second log in there. So I'll hit my log button again, Then I'll type the parenthesis. There's a 1 plus built into my formula. And then I have the decimal divided by 1. Since it's being divided by 1, I don't really need to type that. But if it was compounded monthly and I'd be dividing by 12 or something, I'd need to. So I'm going to write that out. So again, this division, this fraction bar is division. So I have my decimal divided by 1. Then I need to close that parentheses. And then the last thing I'm going to type is another divide by 1. So I need to type all of that into my calculator. So let me go ahead and pull up Desmos. Oops. Okay, here's the Desmos scientific calculator. So I need to go to the log button. On Desmos, it's a function. So I'm going to click function and then find the log. It's my log. Then it automatically populated a parentheses. So I have my future amount, that's 120,000, divided by, oh, Desmos made a fraction for me. That's cool. I just hit the division key to do that. Now I'm going to pop out of my denominator and close the parentheses. Then that was getting divided by, oh my goodness, Desmos made another fraction. That's cool. I'm going to go hit my log. It opened to parentheses. And now in my parentheses, I have 1 plus, then the APR is a decimal, divided by, what? Yay, Desmos, another fraction. I hit my division button to create that fraction bar there. Now I used my arrow key to pop out of the denominator. I close that parentheses. Then I'm going to use my arrow button again to pop out of that fraction and hit the division button again. Ooh, okay, so that just did another division bar, but that's okay. And in this case, we're dividing by 1 because we are compounding annually. And then I get here that it took almost 51 months. Years. 50.97. I think it said to round to the nearest year. Our time is in years. Let me go back and see what it said. So 50.97, remember that, 50.97. So let me write that down. I ended up getting 50.97, and it says to round to the nearest year. So that would round up to approximately 51 years. So if I deposited $4,000 in this account that's earning 6.9% interest compounded annually, and I walked away and forgot about it, and never made another payment, never gave it another thought, just let it sit there, right? Don't touch it. In 51 years, that $4,000 will have grown to $120,000 just based on all the interest it earned over that 51 years. Only $4,000 out of my pocket and 51 years of my time. And then the interest did all the other work for me. And I end up with $120,000. So if you typed that expression into your calculator and did not get 50.97, come see me in office hours and we can take a look at your calculator. Oh, wait, you know what I might mention? There's an easy way to check this answer. Since the time formula, the years formula is so tricky to use with those logs. Now that you know the time, you could go back and use one of the easier formulas and use this amount of years, 50.97, and see if you get close to the final amount. Like, for example, let me just pick out another formula real quick. The A equals formula is much easier to use. So if I say I initially deposit $4,000 at an APR of 0.69 compounded annually, and then so my exponent would be 1 time a year and you want to use as many decimal places as you can to get the most accurate answer. So what was that? It was, let me go back to Desmos real quick. It was 50.9744. So I'll use that, 50.9744. If I type all of that into my calculator, which is much easier to type, it's calculating my future amount. So I'd want that future amount to be really, really close to 120,000. I mean, there's going to be some rounding because I rounded that year. It's not a terminating decimal. It wasn't an exact amount. So it's going to be like really, really close to 120,000 if I type that in. But that's a way to check yourself if you're really unsure if the number of years you got is correct, because you're really unsure if you typed it in correctly. You can just use that information on an easier formula just to kind of see if it was even in the right ballpark. Okay, now if you have any questions, come see me in office hours.